companies start exploring for oil and gas deposits with geological, magnetic, gravity, and seismic surveys. When a promising location is found, an underwater tower, called a jacket, is installed on the seabed. The jacket will help guide the drill pipe for drilling, and if oil is found, a topside will be installed on the jacket to hold construction facilities. A drill crew is then brought in to drill the well, which can take somewhere between a few days to months to complete. When oil and gas are found, the well is capped with a wellhead, and construction begins on a production facility to produce oil and gas. Jackup drilling rigs are mobile offshore drilling units, or MODUs. Semi-submersibles and drill ships handle deep water drilling of up to 12,000 feet of water, but MODUs excel in shallow and coastal areas of 400 feet or less. Instead of floating above the well for drilling, they are what is referred to as bottom-supported units. In other words, they rest on the seabed. Most wells are drilled by jackups, although new wells are being found in deep water, as most coastal areas have been heavily explored. These rigs use retractable legs to stand above the waterline and perform underwater work, acting as a floating barge that turns into a stable platform above the waves. Jackups typically have 3 or 4 legs that are extended down to the sea floor. The drill is either cantilevered over the side of the vessel or mounted to be used through a slot in the hull. Jacking up the rig on the ocean floor creates a stable platform above the waves on which it is easier to work. All of this is to support the drilling process, so the rigs have to be ready to relocate when drilling has finished. When it's time to move, rigs retract the legs up, which can make them somewhat unstable. Once up, there are 3 options for movement. If the distance the rig needs to travel is long, the rigs stay up high and a heavy lift ship floats underneath the rig, filling its ballast tanks to stay low in the water. Once in position, it can empty the tanks and the rig can be lowered down onto the ship and transported. For shorter journeys, rigs can also be towed into place, many times after being transported on a ship for the longer leg of a journey. Rigs are basically floating barges, and are subject to the same standards as other ocean-going vessels, and governed by the same classification societies. The self-propelled variants are less common due to the large power that such units consume. During the floating transit mode, the legs can be used to handle wind and wave loading. By lowering the legs further into the water, without touching the seabed, the vessel becomes less responsive to wave loads and more stable. This is particularly useful when used in conjunction with ballasting. A jackup barge is comprised of 4 main parts: the buoyant and watertight hull on which machinery and deck space is located, the legs that are used to jack the platform vertically, the machinery that is used to move the legs, and the bottommost region of the legs, known as the footing. Spud cans are a common type of footing used in modern jackup platforms. The hull is an enclosed structure made of steel, capable of withstanding hydrodynamic loads while floating and stationary. The machinery is stored on the hull, and it is usually divided into 3 decks. The hull on which these legs are built is watertight, buoyant, and similar to a ship. It has ballast tanks, living spaces, if required, a bridge for operators to work from, and machinery for lowering and raising the legs. The uppermost deck is where the living quarters and helideck are. It is also used as a storage site for heavy machinery and essential items. The intermediate deck is known as the equipment deck, where the drilling rig equipment is housed. It also includes the machinery that is used to move the legs vertically. The lowermost deck is used to store grout or drill mud and store the drilled oil and gas. During transit and when the legs do not touch the seabed, the barge is fully dependent on buoyancy for supporting the hull weight. When the legs are anchored in the seabed with the footing, that means the weight is supported either solely by the leg reaction force or partially with buoyancy on the hull, if it is in contact with the water. Legs of a jackup are a strong lattice structure. The verticals on the outside of the structure are called chords, which can be triangular, in groups of 3, or a square cross-section with 4. Legs can also be columnar, but this type of leg is not as strong as open truss legs, so they are only used on vessels that operate in less than 250-foot water depths. The type of machinery used to retract and extend the legs vary depending on the platform, but the most commonly used systems are the mechanical rack and pinion mechanism, and the hydraulic ram pinhole mechanism. The rack and pinion system makes use of a gear mechanism that works by rotating a pinion about a rack positioned on the leg. The pinion, on the hull, is part of the hull and climbs up and down the leg using motors that power it. The hydraulic system is also very common and makes use of a series of rams that can slot into holes along the platform leg. It works by sequentially moving the ram into the hole, hydraulically moving the hull, and then locking it into place. There are 4 rams, 2 upper pins, and 2 lower pins, separated by a vertical piston. The legs actually sink into the ground, and usually contain jetting lines that agitate the seabed to help the legs sink deeper, as well as loosen the legs when it's time to move. The bottom of the leg is called a spud can, and this acts as a cleat to dig in and keep the rig in place. In case the deck is being lowered into the water, the ram pins first lock into their holes. Then, the upper pins release, the pistons contract, and then the upper pins move downwards. Then, they lock into place, the lower pins release, the pistons extend, and then the lower pins again lock into place. This way, the mechanism retracts and extends the legs. The process is in reverse in the case of raising the hull. The jackup barge is towed to the installation site, with minimal machinery and equipment on board. Any loose items on deck are secured to prevent any accidents during the subsequent operations. The legs are then lowered into the water until it reaches the seabed. The leg extending machinery pushes the legs further into the seabed, while the hull floats. Jackups also have ballast tanks, which can be filled with water to preload the legs and drive them down for solid footing. It also ensures that there isn't a false bottom where a rig leg could fall through and be damaged. The hull is then deballasted, and it begins to climb the legs away from the surface. The hull exits the water and maintains a sufficient air gap. Lastly, any moorings are removed, and the jackup barge is allowed to face environmental loads without any external protection. To allow the spud cans to properly grip the soil and the legs to sink into the seabed, the downward load on them is increased by ballasting the hull. This increases the weight acting on the spud cans and secures them in place. Preloading is a safety procedure since it ensures that the soil can take the hull weight without slipping. In case of foundation failure at this stage, the hull will only sink below the surface, while there will be no fatalities. When it is time to shift to a new location, the spud cans are loosened by pumping water through nozzles, to dislodge it from the soil or clay, the legs retracted, and the hull immersed in the water.